Since f equals a to the x is always increasing or always decreasing when a is not equal to 1, it has an inverse of its own. It's a one-to-one function and has an inverse. And we denote that inverse by log to the base a of x, which is denoted by this symbol on the right. We have the following properties, which follow from the general properties of inverse functions. From the law which says f inverse of x equals y is the same as saying that f of y equals x, we get log to the base a of x is y is exactly the same as saying that a to the y equals x. And we also have from our composition laws that a to the power of log to the base a of x is x itself, and log to the base a applied to a to the x is also x itself. It's also not difficult to show that log to the base a of x has very similar properties to the natural log of x. In fact, it's a constant multiple of the natural log of x. And the exact relationship is shown here by what we call the change of base formula. So log to the base a of x is the natural log of x divided by the natural log of a. And of course, the natural log of a is a constant here. Why is this true? Well, if y equals log to the base a of x, since a to the x is the inverse function, we must have a to the y equals x. So taking the natural logarithm of both sides, we get y times the natural log of a is the natural log of x. And now, solving for y, we get y equals the natural log of x over the natural log of a. But since we started with y equals log to the base a of x, that gives us our change of base formula. Now the algebraic properties of the natural logarithm extend to general logarithms using this change of base formula, which just says that log to the base a of x is this constant multiple of the natural log of x. So we have log to the base a of 1 is 0, because it's 0 over the natural log of a. Log to the base a of x times y is log to the base a of x plus log to the base a of y, and log to the base a of x to the r, for any r now, is r times log to the base a of x. And this is true for any positive number a not equal to 1. For most calculations, it's advisable to convert log to the base a of x to natural logarithms and use this change of base formula to calculate, differentiate, and so on. The most commonly used logarithm functions are log to the base 10 for things like the Richter scale and so on, and the natural log, which is log to the base e, because it's the inverse of e to the x. We can use the change of base formula to derive a differentiation formula for log to the base a of x. We have its derivative is the derivative with respect to x of 1 over the natural log of a times the natural log of x, which is 1 over the natural log of a times the derivative of the natural log of x, which is 1 over the natural log of a times 1 over x. And using that formula, we can also come up with a formula using the chain rule, which says the derivative of log to the base a of g of x is g prime of x over g of x times the natural log of a. Once again, it's much better to remember one basic formula, the derivative of the natural log, remember the change of base formula, and all of these formulas follow using both of those together.